All right, hope you're well rested. We're going to learn a little bit more on our way to figure out merge sort by looking at the merge method that's actually used in most implementations of merge sort. Now, here's the difference from the problem you just previously did in the last video, which was merge two separate sorted lists into a third list. What I want to do this time is I want to basically merge two sorted portions of a list and save the answer in our original array. So easier to show you here, but here's the general idea. Here's an array, and my array is not sorted, but there's two sorted portions. You can see here from slot 0 to 5, that's one sorted portion, and from slot 6 to slot 11 is my second sorted portion. You can pretend in your head this is sort of the same as being given two sorted lists. The only difference is I have to sort of remember, well, I only have one array, and I have to remember the numbers 0, which I've called left position, the start of the left list, 6, which I've called right position, which is the start of the right half of the list, and 11, right end, the end of the right half of the list. Now you may be wondering, well, don't you just know 0 and 11, it's the begin and the end? Not always. You're going to see this take a step further later on, so just trust me, we want to keep track of where the end, the start, and the start of the right half is. Now, what we end up doing is we end up doing the exact same method you guys did before. We want to run a merge routine, and we basically want to say, hey, I'm at left position, I'm at right position, which one's smaller? Well, I know the one is smaller, so what do? I go to a temporary array that is set up to be the exact same size, and I put the 1 into temp position. Temp position, by the way, starts out with the same value as left position. Left position was 0, temp position is 0. Now what goes on? Well, temp position moves up. After temp position moves up, left position also moves up. And then you continue on with your routine. Hey, what's at left position? What's at right position? Well, I'm going to take the 2. So I put the 2 in there. Temp position moves up. Right position moves up. I'm going to take the 3 compared to 5. The 3 is going to go in. The 3 goes in. Temp position moves up. Right position moves up. Anyways, this is exactly the same routine you guys did before. Now, what's the end point of this routine? Well, the end point is when left position has moved its way up past left end, or right position has moved past right end. So it's exactly the same as your code before. We just have sort of different variable names this time. Now, I'm going to fast forward to where one of the lists is done. And we can see here that if I actually just take these out, I'm going to take the 3, then I'm going to take the 4, then I'm going to take the 8, the 40, the 50, the 55, the 80, the 90. I've left a number out here. Okay, it was way back here. I had number 5, then I had the 8, then I had the 40, the 50, the 55, the 80, the 90, the 99. Now, when we hit this point, I know that left position I think is hanging there. Right position is hanging there. This actually might be one more past. And now, what do? We've actually got our numbers sorted from slot 0, that was left position, all the way to slot 11, which was right end. Now, all I have to do is copy these right into the array here. So basically, I just take those, I go copy, and paste. And there you go. That was the use of the temporary array. It stored the number in orders for us, and then when we're finished, you just do a copy, 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 running down the row from your starting position to your finished position. And then that's it. Now, that's part one. Part two of this is, well, what happens if we'd done this with a much smaller section of the array, not the entire array? So let's do just a quick version of that. Give me a sec here to re-wipe the grid. Okay, I've cleared this out here. Now I just want to sort of emphasize, this will be a really short one here, but this merge method, since it works on the entire array and you get to tell it where to start and where to finish, it's going to be a crucial part of our merge sort routine. For this example, I just want it to do its work right here. So you're going to see where my two lists are. 1 and 5 is sorted. 2 and 3 is sorted. So this is going to be left position. This is going to be right position. And this is going to be right end, where it ends. When I actually go to make my call, which you'll see in the recursive routine later, I'm going to say, hey, start at 0. The right position starts at 2. And the right position of the list ends at 3. What's going to end up happening? Well, it's going to do the routine. It's going to set this to left end. It's going to do the little sort routine, and your result in here is going to be 1, 2, 3, 5. It's this part of the list sorted. Notice the whole temp array doesn't have to be filled. Then when it actually goes to copy the sorted portion back in, it's only going to copy from position 0 to position 3. And so then this gets copied over into there. What this does, bam, is this basically lets us call merge on various portions and sizes within our original array. Now keep that in mind, because now we're going to actually get to show you the code for it. And the code for it's right here. And it's provided in your package. You're going to notice it scares a lot of students because the method looks a little bigger. There's a lot of the variables here, so many parameters going in. But all it is when I call merge, there's my original array. There's the temp array. The same temp array is used every time. There's left position, where right position starts, and where right position ends. Here's the code. You'll notice this is almost exactly what you guys wrote for your merge of two lists. The only difference now, they're involving the temp array. There's the what happens when one of the lists is finished. It just finishes off the other, or it finishes off the other. And there's the final copy, where it goes from temp array and it copies it into your original array, making your original array permanently changed, and that part of it is sorted. Okay, this is going to be a crucial part to our merge sort algorithm. Now you'll see here's the test of it. I'm calling merge on this list from position 0 to 6, and 6 is where the right half starts, and 12 is where the right half ends. And then when I'm finished, I just print out the array to verify that it has been sorted. And of course, it has. And you can see here it's done a nice job of merging those two sorted halves together. Now, once you've seen this, we want you to go peek at the actual full merge sort algorithm at this point. And you can see how this is all put together to code in merge sort. And you'll see here merge sort is actually coded up in the file here. That's it. Once you have that merge method written, all it is this nice, easy, recursive sort that we'll take a look at in the next video. Thanks for watching.